This video is on prime factorization and identifying groups of numbers. First, we'll talk about prime factorization. Prime factorization is finding all of the prime numbers that multiply to a given number. We also call those factors. So it's finding all prime factors of a given number. So let's remind ourselves of a couple of tips that help us decide what numbers might divide into a number evenly. Remember that if a number ends in 0, 2, 4, 6, or 8, that number is divisible by 2. It's called an even number, so it divides by 2. Another tip is that to find if a number divides by 3, we add all the digits and see if that number is divisible by 3. If it is, then the original number is divisible by 3. The last tip is if your number ends in 5 or 0, then we know it's divisible by 5. When finding prime factorization, it doesn't matter the order you divide them. You're just looking for whatever factors you see and do those first. So let's look at example number 1. In example number 1, we need to write the prime factorization for 660. So first, 660 ends in a 0. So I know from my tips above, I can either divide by 2 or 5. I usually start with the smallest prime and work my way up. So let's start with 2. But remember, it doesn't matter which ones we start with. So if I do 2, then I need to do that 660 divided by 2 is 330. So the notation I'm using is I'm showing that 660 divides by 2 and 330. When I'm doing my prime factorization, I also like to circle my numbers that are prime numbers so that I have an easier time finding them when I go to list them in the answer. So now I need to divide 330. Well, again, it ends in 0, so I know it's divisible by 2 or 5. So let's write the 2. 2 is a prime number, so I'll circle it. So let's try 330 divided by 2. 2 goes into 3. Two goes into 330 165 times. 165. Well, that number ends in a 5, so I know it's divisible by 5. So let's do that. And that's a prime. So 165 divided by 5 is 33. 33. Well, it doesn't end in an even number, so I know it's not divisible by 2. It doesn't end in a 5, so I know it's not divisible by 5. Let's see, if I add those two digits, 3 plus 3 is 6. 6 divides by 3, so 33 must divide by 3. So 33 divided by 3 gives me 11. So 33 divided by 3 is 11. 11. Well, it doesn't end in a 2, 4, 6, 8, or 0. It doesn't end in a 5. So it's not divisible by 2 or 5. If I add the digits, that's only 2, and 2 doesn't divide by 3. So 11 is not divisible by 3. So now I have to start dividing to see if 11's prime, if I can't remember if it's prime or not. So I know it doesn't divide by 2, 3, or 5. So the next prime number is 7. Does 11 divide by 7 evenly? 7 goes into 11 one time with a remainder. So it doesn't go in evenly. 11 is a prime number. It's the next prime number. So 11 is a prime. So now that I have no more numbers that aren't prime to divide, I can list my prime factorization. My prime factorization would be 2, and I have 2 2's, so 2 squared. Remember that little 2 up top is called the exponent. It tells me how many of the base number I had, times I have a 3, and I have a 5, and an 11. So the prime factorization of 660 would be 2 squared times 3 times 5 times 11. Now I would like you to pause the video and try practice number 1 on your own. Okay, let's try this one now. So it ends in an even number, so I'm going to divide by 2. So 387 divided by 2 is 189. So 2 is a prime. 189. It's not even. It doesn't end in a 5, so let's try adding up the digits and see if it's divisible by 3. So 1 plus 8, 9. 9 plus 9 is 18. 18 divides by 3, so 189 must divide by 3. 3 goes into 18, 6. 3 goes into 9, 3. So this is 3 times 63. 3 was our prime. 63. 63 is 6 plus 3 is 9. Again, 63 will divide by 3. So 63 is 3 times 21. 21 is also divisible by 3, and it's 3 times 7. And we know 7 is a prime, so we can stop. We have all prime numbers. Now we just need to list them. So 2 times 3, and I had 1, 2, 3 3's, so 3 cubed times 7. So your answer is that. Let's try another example. So 266. It's an even number, so let's start by dividing by 2. 266 divided by 2 is 133. 133. Well, I don't know. It's not even. It doesn't end in a 5. So let's see if I add the digits up. 3 plus 3 plus 1 is 7. 7 is not divisible by 3, so it's not divisible by 3. So now we have to start dividing by our primes in order from smallest. So the next smallest prime I have is 7. So does 7 divide into 133? 7 does. It's 7 times 19. 19. Well, 19, 1 plus 9 is 10, so it's not divisible by 3. It's not even. It doesn't end in a 5. 7. Does 19 divide by 7? No, it doesn't divide by 7. 11 was our next smallest prime, so does 19 divide by 11? No. Our next smallest prime is 13. Does 19 divide by 13 evenly? No, it has a remainder. Next would be 17. Does 19 divide by 17? No. So 19 is also a prime number. I've tried all primes smaller than it, and it is also prime. So 2 times 7 times 19 would be my prime factorization for 266. Please pause the video and try practice 2 on your own. Okay, let's see how we did. So even number, divide by 2. That would be 408. Divide 408 by 2, I would get 204 still divides by 2. $102 still divisible by 2. And 51. Not even, so not divisible by 2 anymore. Let's add the digits. 5 plus 1 is 6, so this is divisible by 3. Three times 17. And we also know 17 is a prime number, so I have found all prime numbers that multiply to 816. 1, 2, 3, 4 2's, so 2 to the 4th times 3 times 17 would be our solution. Next, let's talk about identifying groups of numbers. So first we need to remember what each of these groups are that we are going to identify. So the first group we have is odds. Odds are numbers that end in 1, 3, 5, 7, or 9. Those are odd numbers. And then remember, even numbers end in 2, 4, 6, 8, or 0. It's also asking us about primes. So prime numbers are things like 2, 3, 5, 7, 11, 13, 17, 19, and 23 are the first few prime numbers. They go on forever after that, but those are the first few prime numbers that we know. The next thing it asks is squares. So squares, remember, we find by multiplying a number by itself. So first square number would be 1, then 4, 9, 16, 25, 36, and so on as we multiply a number by itself to get our perfect square numbers. We should know our perfect square numbers up through 12 squared, which is 144. We should be able to recognize all of those numbers in between. The last group it asks us about are cubes. And remember, cubes are numbers where I multiply a number by itself 3 times. So 1 times 1 times 1 would be 1, 2 times 2 times 2, or 2 cubed would be 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. We only need to recognize our cubes through 125. So now let's look at example number 3 and see if we can identify this group of numbers. Are they odds, evens, primes, squares, cubes, or none of the above? So let's start first with odds and evens. Well, 2, 4, and 8 are all evens. We have no odd numbers in there. So our group might be evens, but let's check and see if they're an even more special group such as primes, squares, or cubes. Well, 2 is a prime number, but 4 and 8 are not prime. Squares. Well, 2 and 8 are not squares, but 4 is a square. And lastly, cubes. 8 is cubed, but 2 and 4 are not cubed. So when I look at these, the only one that had all 3 of the numbers part of it were evens. So 2, 4, and 8 are all evens. Now I'd like you to pause the video and try practice 3 on your own. Okay, in practice 3, odds. 3 and 9 are both odd. Evens. 6 is an even number. Primes. 3 is prime, but 6 and 9 are not prime. Squares. 9 is a square number, but 3 and 6 are not. And cubes. We have no cubed numbers. So in this case, I have, out of my group choices, I have no group that has all three things in this. So this is a group of none of the above. They are not a group of odds, evens, primes, squares, or cubes. Let's try one more together. So example number 4. Are they odds? Well, the odd numbers we have are 11 and 13. Evens. 2 is even. So they're not odds or evens. Let's try squares. None of them are squares. And cubes. Again, none of those are cube numbers. So the only possible thing we could have is primes. Well, we know that 2, 11, and 13 are all prime numbers. So this is a group of primes. Please pause the video and try practice number 4 on your own. Okay, so odds. 1 and 27 are odd, but 8 is even. So they're not odds or even. Primes. 1 is not a prime number, 8 is not a prime number, and 27 is not a prime number. So we have none. Squares. 1 is a square number, but 8 and 27 are not. And lastly, cubes. 1 is a cube number, 8 is a cube number, and 27 is a cube number. So your group is a group of cubed numbers. That completes the examples for prime factorization and identifying groups of numbers. If you'd like additional practice, please see additional practice on primes factorization and identifying groups of numbers, part 2 of 2.